So here we are today. I want to do a few more lessons from the Splunk material, 7, 8, and 9, and I'll demonstrate some of that. And then I'll demonstrate a few of the Splunk projects and some more Boss of the SOC. That's my plan. So here we are with Chapter 7. And, all right, I wonder if I can get it to fit on the screen a little better. This thing up here. There. And how about moving this over? Looks like I can't. All right, I'll do this. Well, that's pretty grotesque. All right, let me try to download this file and project it in a better projector, or in a better viewer. Here's the class materials. There it is, okay. Save linked content as, there we go. All right. I already have it. All right, pardon me. All right, let me just open it there to make it look better. I'm having trouble with my projection today. 50, lec. Okay, it's coming up. All right. All right. I should be able to make this resize to the right size to fit on this screen. All right. Good, and I saw a question in Twitch saying, I'm unable to launch Splunk even though I have it installed. Okay, well, I'll solve those hands-on, I'll try to help people with those hands-on problems later, although you might find a student to help you now. That would be good. All right, so we're down to Module 7. So here's just some best practices, and as I mentioned, I routinely break these. If you want to be efficient with Splunk and not use too much CPU, then this is the way to do it. I often don't bother because I'm only working in like a training environment. So time is the most efficient filter. Filtering for the right time range will remove most of the events that you don't need. There should be indexes. If you have your data, you should sort your data into indexes by some criteria like location, so you can restrict how much data you're looking at. And just like any other search engine, if you include more terms, I say the actual speed it takes Splunk to find things seems to be dependent mostly on the number of results that it finds. So giving it more search terms, so you have less total results, will run a lot faster, and being as specific as possible. And as I mentioned, inclusion is just logically better than exclusion. Searching for access denied will be specific. Searching for not access granted cost it much more because it has to look at every record and decide if it's not equal to that. So a more specific query is going to use less CPU. So they say filter anything that lowers the number of events, like removing duplicate events, should be done as earlier before you do an expensive activity like sorting. And if you put wildcards in strings at the beginning or middle of a string, that's very expensive. Putting it at just the end is probably best, but this is okay because it will look at the first few letters and be able to exclude most of the events and not have to bother guessing about this until it's got certain events. But this sort of thing, a wildcard like that in particular, is real expensive for the system. And if you can use or instead of wildcards, if you can just say admin or administrator instead of admin star, that would use less CPU. These should be fairly obvious, but anyway, if you care about CPU, there's some tricks to avoid wasting it. So here's indexes. This is index equals security, I think. I can't see it very well. Yeah, index equals security. You can also have multiple indices or even a wildcard in indices if you want to. If you have a big data set, there's many different indices. Now, everything we're doing just has one index anyway, so it doesn't matter for the hands-on projects here, but that's how it works. The index field is present in search results, so you can see the index. To run a search, one way to get started would be to turn on high event sampling, run a search for everything, and then see what indices are available. All right. Now let's talk about the search language. They call this a search language. Now, by the way, there is an actual search language that looks like SQL available, I think, behind the scenes. We can manually write things, although I'm not quite sure about that. I'm thinking about Velociraptor. There's a thing called KQL. I think Search does have their own query language called VQL or something. But what they're talking about here is how to use the search bar right here, which I say is not anything different than, say, a Google Advanced Search. So you can search for something, have an index, then you search for something like access star and status 503. Then you can have a pipe where you go to some kind of aggregation activity. Like this will do statistics, summing price, and renaming that field lost revenue. And then you can go to evaluate. Lost revenue equals a particular value here. And these are just various things you can do. You can do statistics, you can do evaluation of a combined field, and so on. And so here's the kind of components. You have, these are search terms, source type equal access star. Just, you have to find that in the event or it won't pass the test. Then you have pipe. We'll take the output of the previous commands and pipe it into more fields. This is a function, and here's an argument. And another pipe, here's another command, another function, and another argument. Argument goes in the parentheses. So there's 5 basic components. Search terms are what you're looking for, and commands are what you want to do with the results. And if you do the more advanced things, you'll have functions that do things like get a sum with arguments of what to sum. And you can have clauses where you group or rename fields. So here's how it looks. And this, by the way, is the same as all object-oriented languages like PowerShell. PowerShell works the same way. You create an object and you pipe it in and do more transforms and pipe it in to another set of transforms. You can turn on automatic formatting, so it will not all put this all in one line. It will always start everything after a pipe on a new line just to make it look prettier. That's another option. There is coloring, which helps you. I mentioned before, the main thing I noticed is when you get and or correct, it changes to orange. If you accidentally use a lowercase and or, it will not understand it and it won't change color. So that's your clue that it's going to misunderstand you. And commands are blue, and arguments are green, and functions are purple. And you can turn that coloring off if you want, but I don't know why you would. All right, and so table is something I use all the time. This is extremely convenient. As you know, a default Splunk search will just give you a whole bunch of events one by one down below. But if you do table, you can get a nice chart of things. So here's a chart of client IP and actions and product number and status. So that's very nice. And let me do some of these. I prepared some of these to put through the boss of the SOC. So let's try a few of them. Let me get to my browser. All right, so here's boss of the SOC, and I'll just start with nothing. All right, and let me shrink the font a little so the bar shows up. All right, so here I'm going to just, I'd like to go to here, search. This will take me back to a clean, empty search page. All right, and so as we were doing before, I'm going to look at the HTTP events. So I click Data Summary, and I could wait for results, and as a student pointed out to me yesterday, I can just search for like HTTP, and it will just find the HTTP source type with the filter. So now I got stream HTTP, all right, and it didn't find any events. Does anybody know what's wrong? I hope you do. All time, that's it. I'm only looking at the last 24 hours, but these events are many years old, so I have to use all time. All right, now I'm going to see some events, and I'm going to turn on sampling because I don't need to see all the events. So now I have 251 HTTP events, and if you don't do anything with it, you'll just see them down here one by one, and that's not very good if you want to understand a lot of them. So let me, so you might make a table. So let's make a table. Now, when you make a table, you have to tell it what fields to put in the table. And so down here, for example, I have client IP. So let's make a table of client IP. Of CIP. All right? So now instead of just showing everything about every event, it's going to just show me the client IP of every event. But you can see it's still not very useful because I have 226 of them, and it just repeats the same number over and over. So that's not as much fun as you might like. So it might be good to remove the duplicates. And you do that with dedupe. Dedupe by client IP. And then make a table. There. And I've got to get rid of that V. There. So I dedupe client IP, and then I send that into table. Now, I'll get just a list of the client IPs, and that's it. So that was more useful. All right. And let's go back to the slides.
Can I have a question?
Yeah.
Is there any way you can do anything to Python API call, anything like that?
To do what?
An API call?
An API call. Oh, well, you mean if your log contains information about an API call, then you could be using those fields. And do you mean remote control Splunk with a Splunk API? I have not heard of that. It's a very good question. I do not know. It might be possible for Splunk to be controlled by an API, so you can like have an app on your phone that queries from Splunk. I imagine. It's a good question, and I've never tried it. It seems like that would obviously be useful, and I know databases often do. I bet something like that exists, but I haven't tried it. Anyway, all right. So you can rename fields because, you know, when you get a table, I wonder what the name was in my table here. My name here was just CIP. And if I didn't want it to say CIP and I wanted to call it something else, I'd put as client address. You can give it a more meaningful name, which is good, you know, if you're going to give this to, say, your boss. Oh, there, client address over here. Huh, all right, let's see what I have to do. Let me go back and see if I can figure out what I did wrong. You can rename fields in a table. I guess I have to rename it first. So here's an example. Rename it. After you make the table, then you rename. Okay, let's try that. Rename. So a pipe to rename. Rename CIP as. I think this might do it. Let's see. Yep, now it changes that name there. That's all. Just something you might do to make it easier for people to understand. All right. By the way, after you rename a field, if you then pipe it and do further things with it, you have to use the new name. It doesn't remember both names. All right, and you can extract certain fields with just fields. So here you'll see, here. This is where it searches for fail or invalid, and here I specify, instead of giving me everything, give me just certain fields like user, app, and source IP. And you'll still get a list of every event, but you'll only see certain fields. So I should be able to do that one, pipe fields. It's similar to table, but not quite the same. So I can do fields. I can do just one. And then I'll get, all right, let's go take a look. I thought I would only get that one. What have I done wrong here? Pipe fields. It puts them, allows you to include in a search or report, exclude fields used in the search. This one was user, app, and source IP. And, well, I'm not understanding what's going on with this fields thing. Display network failures, retrieve only user, app, and source IP. Well, it sure looks like you still retrieved everything. So I don't understand what's going on with the fields thing. Maybe we'll figure that out. I'll be able to look into that later. Maybe a student can figure it out. The fields doesn't seem to do anything in either their example or when I do it. So it may be something to research later. Anyway, we used dedupe before. That was useful. And sort is, of course, useful. You can sort things by anything you want, which is handy. But what's even easier, and really the only thing I've ever used, is like top and bottom, top and rare. Top is the easiest way. You notice one thing that happened here. When I did the original query, let me get back to my notes here, which was table of client IP. Okay, I don't understand that fields thing. Let's do table of client IP. All right, if I do table of client IP, I get all these client IPs, and even when I put dedupe in it, I put dedupe here, then I got a list of client IPs, which is unique client IPs, which is somewhat useful, but I didn't get any more information about them. I didn't get told, I got a dedupe on client IP, pardon me. All right, I didn't get told how many of these IPs came in. So that wasn't as good as I wanted it to be. So what's easier is to use top. And let me go back to my example here. So you pipe top on the client IP. Okay, so here, if I do top, then I get a very nice chart with all the values and how many times it happened and even the percentage. So that's quite useful, and the opposite is rare. This gives you the top 10, and the other one gives you the bottom 10, and you can change that with limit if there is more than 10. So anyway, that's quite useful and easy to use. You get top 10, you can change the limit. You can change whether you want to show the percentage or not. And I think count fields just lets you change the name of the count, because this field is called count, but you might want to give it a more descriptive name. All right. You can have multiple fields there. So let me do count. Yeah, you can have top client IP and say HTTP user agent. All right. And now I get client IP and user agent. There's only one user agent with that IP, but here it is again. Okay, so there's two different user agents by that IP, so it split those into two groups and gives you the count and percent. So this is quite useful. All right. And you can have by also. There's another way to do it. You can do one field by another field, and then I think you'll fix this problem. Remember, I wanted to say how many different user IDs came in with 40, but they were separated. If I put a by instead of a comma here, I think it will organize them this way. Yes, so now I've got a client IP of 40, and this, now I don't see the two different entries of 40, and that's troubling me a little, although I think those were the two entries, Mozilla and Chrome. Let's go back to the previous one. If I do count, let's just look at 40, see if we can understand what's happening here. Okay, there's a 40 with Mozilla, and there's no other 40. I thought there was a second 40, but I'm wrong. Let's take one that has two. Well, I'm not finding one with two anymore. All right, maybe my example here is not going to show what I was hoping it would show. No, here's one. This 21 address appears twice with Python and Mozilla. Okay, so let's look at the 23. Sorry, it's so far away I can't see it. There's a problem with the projector in this room. Okay, the 23 has two different user agents. So let's see what happens when I use by. Here's the 23, and okay, it actually had three different ones, which somehow I couldn't, has four different ones, which somehow I couldn't see on the previous one. So I'm going to spend another minute on here. I'm very confused. How can there be four different ones here, and there were only two different ones here? Something is strange and inconsistent here. Client IP, HTTP user agent. Is it just scrolling off the bottom? It's not. So all right, something is very strange. And I don't understand why I'm getting different results from these two things. Let me see if I can understand anything from the lecture, otherwise I'll just keep going. I use top quite a bit, although I only do one field. When you do one field, the answers are easy to interpret. Doing two fields, single field by clause. Display the top three users for each web category. Yeah, that's top. Was I doing top? I was not doing, I'm doing top, that's why. Oh, I'm only doing the top ones. Okay, so I'm not seeing them all. Okay, so let me try this again. If I change the limit, that's only going to 10. No, there's not even 10 here. Let's go to limit. A limit 100. See if that helps. Well, my demos are collapsing on me here. Let me see if I can create, I'm not helping any if I get things so confused. Top, common fields limit, let's see, okay, with limit equals 20, okay. Limit equals 100. See if we can get them all. All right. All right, now, if I take the 23 address, I still only have, well, now I have three values, okay? All right, so that's something. And if I make it by, then I have only 2. All right, I'm buffaloed by this. I don't understand why I'm getting different results for queries that should be the same. All right. Now I know why. And some of you should have caught me. I have filtering turned on. I'm only looking at 1/100th of them. So every time I repeat it, I'll get different random numbers. That's why. Let's turn off the filtering, the sampling. There. Now we should get consistent results. All right. So now I just have a lot of results, but at least I'm going to get consistent results. Top HTTP by user agent. All right. So I'd have to put in something else to limit it. Let's put in something that worked in the chart, not Acunetics. This will get rid of the stuff from the vuln scanner. In fact, here, let's just do the ones that have Acunetics in it. Those will be all from one address. All right, now I feel better. There shouldn't be that many of them. All right, and these are all the things from the Acunetics. It has a lot of different user agents, but if I do just the client IP without the user agent, those all came from one address. Now, if I don't do a summary, now we're getting somewhere. If I don't do a summary and look at these events, then let's find something that only has a reasonable number of values here, because the user agent, when you run a vuln scanner, will not have just one answer. It'll put all kinds of junk in there. But action has only 2. That might be good. Let's see if there's anything that has more than 2. Here's something. Data package in has 6. That's an appropriate number, but kind of boring. Event type, that might be interesting. All right, let's do event type. There's different kinds of event types that came in. Oh, HTTP method, there. HTTP method, that's a very good one. So let's play with HTTP method. So now, if I pipe this and look at, say, top, client IP, then I'll see, of course, just one IP with a whole lot of events, 20,000 events. But if I do top IP and HTTP method, then I should get a useful chart. And there we are. Now I get the results of the 6 different methods. Most of them are post, some are get, and so on. And now if I do one by HTTP method, we can see the difference, which should just be the same information formatted differently. Yeah, we're getting the same information with the client IP and the method, method being the dependent variable, the independent variable, this being the dependent variable. All right, now that's a better example to work with. So let's go back to the, all right, so now I should be able to do fields. Let's see, what else is, I've got a top command with a single field. And here we did top username. All right, you could also just put a comma between the two, and we've done that, I think. All right, and you have a by clause. All right, now you can rename the count field, and you do that with count field equals string. So right here, that's called count, but I could say count field equals number. All right, number of requests. Spelled it wrong, but that's all right. I got to spell count field correctly, though, or nothing's going to work. Count field and number. There we go. I just changed the title, so nothing very deep, but it can matter a lot when you're making yourself look good to your boss. All right. And then rare, just as the opposite of top, instead of the most common fields, it shows the rare one. And stats lets you calculate statistics. And this one is interesting to play with. So you can do stats count. Simplest thing is stats count. So let's try that. If I go back and get rid of all this, and just get all the events that came from the vulnerability scanner, I will get. It'll take time. Like I say, it takes longer when you find more results. There's 20,000. I think it's going to be 40,000 when it finds them all. Okay, looks like 20,926 events. Now I can pipe this to stats count. All right. And now I just get that one number, which will turn into, when it's done, 20,000. Now, that's one way. I can also use the as clause to rename it, which is not that exciting. And now I can do count of field. Then it would count a specific field, and if that field is empty, it wouldn't be included in the count. That's actually caused more problems for me than it's solved. But counting by is quite useful. So now if I wanted to filter that, I could do by HTTP method. All right, and that should give me that same chart again another way. Yep, now I get the method and the various counts. All right, and this is the reason I really like this kind of chart, this is what I learned. I was a database administrator for years, and I learned how to use a much more primitive database than Splunk. But you could do these things to catch errors in databases, and I did it a lot. We did financial databases, and you could add up the data one way, add it up another way, do counts for things, and you could quickly find outliers. Like you'd count things, and you'd see most of them are get and post, but there's just a few that are strange. And then you go examine those anomalies. This is also true in threat hunting, which is what you mostly do with Splunk. You have to somehow find a way to get the normal traffic into a bucket and find the exceptions, and then look at the exceptions. That's basically what threat hunting is. Look for things that just don't look right. And being able to cut the data by all these different parameters is how you find them. So distinct count will count the unique values instead of just the total. And you can also sum fields to get the total, and you can do things like average and so on. So, all the mathematics is available for things like counts and money. And you can list all the field values and so on. There's a bunch of different statistics available to you. And you can format those tables. You can color code the data. You can add currency symbols and so on to make it as pretty as you like. So you can take something and go into the menu and make it show up with like highlighting values that are above a certain value and adding all sorts of pretty formats to it. Although realistically, I think you'd do a lot better off to move it into something like Excel to add the beautifying stuff. But you can do some of this inside Splunk. All right, so that's all I wanted to show you about the lecture. And now I just want to talk about the projects. Let me stop this recording.